Hello, my name is Rich Howard, owner of Architectural Builder Supply, and this video is to bring you a closer look at the Stanley, their part number BB159. This is a double-acting floor pivot, and it is in the US4 finish, or 633 finish. Probably going to be a good finish to call this. Here's what the box looks like when it comes out. This type of format of double-acting pivot I can attest to having seen. I can't attest to them being around for 70 years, but I can tell you that I've seen them installed in applications several decades after the original installation. So this design has been around for a real long time. Is a very typical and common item that you're going to see mostly in residential applications, and where I have personally seen these installed in countless areas are in residential applications separating a dining room from a kitchen. Simply put, I've also had clients order these from me and install them between like a hallway that leads from a kitchen hallway to a mudroom that will then exit out, to the garage kind of scenario. And it's nice because it will keep that area, kind of visually separate, but not necessarily separating it per se. Certainly seen them installed in restaurant applications, although I think I think it would be certainly something that can work in a super high volume application for a while. But hydraulic control might be better for such an application. A spring is just going to potential energy, stored energy, release, clack, 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 that kind of thing. I don't know that that's necessarily what you want to have in an application like that. You might want something that will give you some control over the item. Now, this is a BB159. We're going to go over what the darn thing is a little bit more, then we're going to talk about everything that I can talk to you about it. So this is for low frequency doors, residential double acting, 1 3/8 to 1 3/4 thick, weighing up to 75 pounds. And you're certainly going to want to adhere to that guideline, because I've had people install these on doors that, why doesn't it work? How heavy is your door? I don't know, 150 pounds? Okay, stop. No, it's not supposed to work. So be mindful of that. If you're dealing with a door that heavy, you really ought not be looking at spring control or spring closing over something. You need control, hydraulic control. So 1 3/8 to 1 3/4 thick, up to 75 pounds. That's pretty much going to handle a solid core door that you'd see in a residential application. You could get into the, if a 3068 door is, let's say, 6.5 pounds per square foot in a solid core, let's just say 20 square feet. Yeah, you can certainly exceed 75 pounds by quite a bit. So be mindful of that. If you have need for a heavier capacity, I'd like for you to reach out to us and we'll help you find an alternate solution. This is a hold open model that will hold the door open at approximately 90 degrees on either side, and that's achieved by the design of this, which we'll go over in a moment. Ball bearing located at the top of the hinge carries the weight of the door and takes the thrust of spring. Ball bearing located at the top of the hinge. Well, what they must be referring to is the top pivot. This is a really common pivot that you are going to see. And they must be meaning this bushing that's here. So the top pivot doesn't really do any work. It does zero work at holding the door. That's all borne by the floor. But I think what they're saying is the force of that door cycling is going to be borne on this bearing that's here. Well, they say ball bearing. There's no ball bearing in this at all. Anyway, I would say that this inserted bearing would be what they're referring to. Okay. Now, let's move on with the extended description. Now, continuing to move through the description, hardened steel roller working with the cam ensures easy and noiseless installation. I have had clients, I have had installations of double acting hardware done in the past, and the hardened steel roller is this right here. That is this little guy right here. That spins. There's one on either side. That, and I can almost do it by hand because this is a lightweight version of this. Well, there's a yoke that is on the interior of this preparation, like a bird's mouth, that when you crank it out to 90 degrees, it's going to sit over that roller and stay there until you push it. That'll provide the hold open functionality. But the hardened steel roller working with the cam is that yoke area, ensures easy and noiseless operation. I've had people say, there are videos on YouTube that there's mystery sounds that occur on this hardware. And I have seen it personally on more than one occasion. I've seen it demonstrated to me online. But what's interesting is when you take the hardware off the door and screw it down to something and then work it manually, you can't replicate the sound. The first time it happened, person in the shop was looking to cut a corner, and we had to cut a corner for this to fit it in, but looking to save time, and cut the top of a stave core door off, or cut the bottom of it, and then prepped the hardware immediately to that stave core. Stave core, think butcher block, same concept. And I told the person that's a bad idea. You need to re-rail that, cut all that out, put in a solid piece of lumber. Sure enough, it goes to the job, and it's clicking. That's the micro movement of the wood on the inside. I just went to a job about 4 months ago. They've got Rixson floor closers installed. There's a clicking sound. It's the wood. They've got Southern Florida. They have wood doors installed on an exterior application that may be about 10 years old, and they've worked faithfully. But over time, that wood's going to work loose. The veneer was clearly succumbing to the moisture. The wood inside was probably no longer at all attached to its core, to its rim perimeter, the stiles, the rails. I could tell by putting a mirror underneath the door that they had been field prepped for the giant Rixson floor closer arms, the bottom arms, and there was probably very little wood left there when the 1.5 inch screws were running through. So when you encounter that sort of clicking, it's probably a loose internal member of the door and not the hardware. These people, the Stanleys, the people that make double acting pivots, they go a long way to make sure their hardware doesn't come back. And in all instances, when I've bolted it down to the workbench and tried to duplicate that sound, I can't duplicate the sound. You screw it back to the door and you hang it, now you got a clicking sound. Something loose is moving on the inside. When you prep, you have to have solid reinforcement for this to go to. And in fact, if I was going to do a door with this, or if I was going to do a door with overhead or floor hydraulic double acting closers, I would use structural composite lumber. I would use a solid sheet of structural lumber so that there's no chance that anything's going to move. You know, you're going to mortise this. When we get to the template, you're going to take out so much of the door, there's literally nothing left after you've prepped that door. There's nothing left. The video I saw on YouTube was a stile and rail door, and I'm going to guess that it wasn't 8-quarter lumber that was planed down and then run through a shaper and everything glued together. That was probably veneer put down to a core, which could be a lumber core, something that is exactly not solid. Anyway, be mindful of that. Nothing worse than getting your nice hardware and then it doesn't work right. Spring tension is fully adjustable. We'll go over that in a moment. You can literally set that. The set consists of your top pivot, and that's actually put together backwards. Consists of your top pivot, Your header portion, your door portion, consists of your decorative plates, and that's where the 633 part of the part number comes in. Satin brass is what 633 means. 606 is also satin brass, but what's going to make this 633 would be the fact that it's ferrous, that it's made of steel. This is a steel-based, this is a piece of steel with a satin brass plating on it. You'll get 2 of these plates, one for each side of the door naturally. The downside of the plates is that they have too many holes in them. When we get to the template review, you'll realize why there's too many holes. But both of the plates are the same, and that's why they have extra holes, because they are completely reversible. If they did not have these bottom holes, they would then be handed. They have this return on the back, and that's for the heel of the door. It's also going to include, oh, your decorative plates were still on that. That's going to be your heel plate. That's going to cover the edge of the door, and you'll see that that's radiused, and we'll talk about that. Fasteners, yes, you're going to get plenty of all of that. You're going to get the screws. You're going to get fasteners to hold the top pivot on. You're going to get 4 screws for the bottom plate. 1, 2, 3, 4. 4 screws that will be in a complementary finish. You're going to get the screws for the face plates. You're going to get the machine screw for the heel plate. That heel plate is going to attach to, I had it upside down before, that countersunk hole is going to go right in here. It's going to cover that off. The rest of your plates are then going to come around and, well, this is going to go over the plates. These plates, what I'm trying to say is, let me just show you, those are going to go on like that. Then your decorative, your radiused plate is then going to fit over that stuff to close that off, to finish that off. Okay. You will get also installation instructions, which are up next, and a tension rod. We're going to go over that too. Now, there is a link below this video to the cut sheet, and let's take a look at that first. That's going to be an overview and summary of what this item is. We've already discussed everything that's on there. It does show you graphically how it's all going to look. Let's move to the installation instructions. So I have installed these. I have shot them. I have sold them. I've done everything with them. And most importantly, I've prepped doors for them. The bottom line is, there's lots of bottom lines here. Let's just start at step 1. You see that they want you to radius that door pivot style. They're not asking, they're telling you. You don't have to, but you're going to have to shift the body over and accept a larger gap between the edge of the door and the jamb. Because why? Well, if you've got a square edge door in a cased opening frame is a flat frame that does not have a stop on it. As I go through the motion, this is a bad example because it would really be going like this. The outside corners of the door are going to hit the frame, and the template here is calling out a 1/4 inch margin. I bet you that with a 1/4 inch margin, you wouldn't have to round that over. I've never tried it, but I bet you a 1/4 inch margin, depending on your door thickness, might be fine. And I think the reason they're giving that to you is because you're probably going to have a 1/4 inch on the other side as well. They're not talking about radiusing the opposite side, the push plate side. They want an 1.5 inch radius. That's an awfully big roundover bit. That's a 3-inch diameter roundover bit. When you have the door radius like that, you can achieve a tighter margin. There's absolutely no question about that, and you will. The template is, in step 4, calling out 1.75 inches from the jamb to the vertical axis of pivoting. That's going to be an imaginary line from the header through the center of that all the way down to the vertical axis of pivoting. That has to be maintained. So if you don't radius the door, you're going to need, based on your door thickness, you might need to kick that over a little bit to accommodate that movement. A 1/4 inch is going to be pretty close to being okay. I would probably opt to make that a little bit larger. If you're going to radius the door, good for you. Here's the bad part about radiusing the door. You need a really giant bit. The last time I bought one, the bit was $200 and some for sure. And they last, because how many of these do you radius? They certainly do last. So what I did was, in a shop setting, if you don't have a $250,000 CNC multi-axis router with a 12 tool changer, you're going to get a good 1.5 horse router. And what I did was I got my really big bit with my bearing, and I took my base and I cut the base out so I could fit this epic bit inside of it, get my depth figured out, just so that my radius would really exit the door really nice. And I'd lay my door down on sawhorses, get my really big router over here with a really big bit, so be careful, that's got a lot of gyroscopic action to it. Get that put on there and put firmly on the door. And it would even be nice if you got really fancy and maybe, and I have never done this because I didn't need to do it, but I could understand why someone would. Maybe make a custom base that's much deeper that will hang on the door a lot more, so you're not just tipping, the half of the diameter of your router base. How much would that be? 3.5 inch? 4 inch maybe. But if you had a custom base that was 12 inch deep, you could really get that on the door and not worry about it moving. The downside of that is, as you pull it down the door, you need to make sure that nothing is scratching. And I have found certain veneers are incredibly intolerant to any tooling or any machining touching it at all. So you're going to want to sand down thoroughly whatever hardware whatever kind of base you might create for yourself. The point I'm trying to make is, when you got a really big heavy tool with lots of RPM and a big piece of tooling in it, it's easy to tip that back and gouge too much of the door out. So you kind of really need to be stealthy about this. Door comes down. If it's a hollow core door, you've got to clamp it down because it's going to move on you. Once you get that rested over here, you're going to want to start the process and then move continually down the door. And as you get to the end, exit straight off. Resist the temptation of going back, because you're going to round over the wrong part of the door. And that same sort of logic holds true at the part where you start. You're going to need to turn that machine on partially on the door, and as you bring the bit down, you're going to need to be straight. That bearing's going to need to make contact with the door. The cardinal rule I use for doing it in the shop is I would make one pass, and then I would make only one more pass. 2 passes, that's it. Taking off any more is just inviting taking off more than you should. Once that's done, take your door, flip it over, do the same thing. 2 passes, you're good. You want to do the other side of the door too, that would be great. Flip it over, 2 passes, flip it over, 2 passes. Now you've got both styles radiused. That will certainly permit you to maintain a much tighter margin between the jamb and the door, and you'll be able to get that to 1/8 of an inch if you want to. And the part that you'll have to determine at some point is, what's my rough opening, or what's my finished opening? What's my door width, and what margin am I going to leave on either side? The template calls out a 1/4 inch. And if you can stuff this closer to the jamb to get down to 1/8 of an inch, it's going to work, is the bottom line. If it's going to be square edge on both sides, you're going to need to increase that. I've seen pivots like this installed in movie theaters, double acting doors from the food prep area to the cash wrap area. They honestly do not care whether that margin is 1/8 or 3/8. They don't care. Nobody notices it. Only hardware nerds like me notice it. But the hardware nerds notice it. And the carpenters probably notice it too. Moving to step 2, they're talking about prepping the top of the door for the top pivot. Super easy. Mortise, 1-inch diameter hole, top of door, based on the center line, from the style of the door to the center line of 1.5 inches. That will match your 1.75 from the jamb. Mortise, 1-inch diameter, top of door and header, 5/32 deep as shown. If it was me, I'd make 3 holes in the door, 1-inch diameter with a Forstner bit. Zip, zip, zip. Same in the header. Nice, flat, the whole 9 yards. I've never made a template for doing this, but I suppose that you really could. That would be kind of nice. Vertical axis of pivoting is what must be maintained. Okay, having that in the proper location. You follow the template, you're in good shape. Then below the top, the cross-section view shows an elevation view of what it's all supposed to look like. You've got to prep that 5/8 of an inch deep down into the door to get the pin inside of it, the top pin. That's all really straightforward. All the dimensions are there, nothing else to call out. Step 3 now shows that stepped prep in the bottom of the door. The bottom line is this. You need to make the first time I looked at this, I said, okay, I need to make my door look like that picture, and that's what I did. And that's where you have to be mindful of what are you cutting into? What are you removing? Is it all particle board? What are you going to be able to screw to? That's all got to be solid stuff. The bottom line is as you look at step 3, anyway. As you look at step 3, they want 3 5/16 from the bottom of the door for the style side. You're going to come in that depth of 5/16. You're then going to work from the other side, give yourself a little prep for the tab that's here, go back, you see 8 3/8 over 13/16. You're going to come up 1 7/16, chop all that out. You're going to make this sort of stepped preparation to your door. You make this fit according to those dimensions and you're in good shape. How to go about doing that would be, I've done it with a circular saw. I've done it with a router. A router's good, but you have to square those corners out. A circular saw is dreadful. Hammer and chisel is no way Jose. I might be really tempted to do as much of that work as I could with a router. And I imagine that's how the factories do it as well, with CNC equipment. Now, the bottom of step 3 refers to a drawing that does not apply to this at all. You don't have to make that groove in the bottom edge of the door because this piece of hardware does not employ any moving pin that would be in the way at all. I know where that drawing comes from. I know what it applies to, and it doesn't apply to this, and I'm just going to leave it at that. Step 4 is secure the thing. Screw it down. Pre-drill your holes. You're obviously going to use your unfinished screws for this part. Okay. Top plate is mounted to the header. Door portion mounted to the door. With someone's help, you're going to get that kicked in, and then you're just going to take that as it's feeding into the top pin and kick it in vertical. At that point, you should really try to do a reality check as best as you can. You're not going to be able to articulate the door much, but you're going to be able to determine pretty quickly if you've got a good size happening there. Once you get the door positioned and everything is shimmed, is margined correctly, your reveals are consistent, mark those holes in the bottom of the floor, into the floor for your 4 screws, pull that all out of the way, pre-drill those holes properly, run your screws in, okay? Step 6 is where it comes into there's too many holes here. Those bottom 2 holes are mystery holes. They're not going to grab anything. These are the only 2 that you'll have something to hit. That's not true. The one on the outside is going to hit. Heel edge. This screw is going to hit because you'll have ample wood there. This has got nothing to go into. Yeah, there's no way. Like I said, if they made these so that they're only proper amount of screws, then they'd all be handed, which really shouldn't be a problem. You'd have one left and one right in each package. I don't see how that's really a problem. I wouldn't want a mystery hole there. I've had people call me up and say, what's that hole for? And I said, cut the top of the screw off and super glue it in place. I don't want to do that. Well, I hear you. I've talked to the factory about it, and that's the way they do it. Very interestingly is the name of the person drawn by Jackson. I know that gentleman. He is exceptional when it comes to technical support. You can see the date of the template that's there. The one that's in the box is March of 2003. And looking at the one online, yeah, it's the same document, Revision C. And at that point, you're really done. And you should literally have decades of faithful service out of the unit. Don't hang something on it that's too heavy. Don't try to screw it to something that's not solid. And enjoy. That's all there is to it. My great-grandparents' home, built in 1944, I believe, or 45, in the late 80s, in the mid-80s, that hardware was still installed on that door and working just fine. Now, they didn't use the door that much because they ate in the kitchen, but occasionally they'd entertain in the dining room, and that's just, that door would then get action. Not very often, though. I found it a novelty to walk through that door as a child. Now, the name Stanley is obviously outrageously synonymous with lots of pieces of hardware. In the realm that I deal in, it would be hinges. Stanley hinges is the line of product that I'm most familiar with from Stanley. Oh gosh. Okay, sorry. Back it up. The adjustable spring tension is not discovered in the installation instructions, so I forgot about it. Tension rod, tension collar. Lefty loosey, righty tighty. Stick that in there, start cranking. Okay, you get the concept of how that works. Leave it the factory setting and then adjust as necessary. You want it to move, you want it to close, you don't need it to move excessively fast. And it's just that simple. So Stanley hinges. I am actually, I sell hinges direct from a few manufacturers, and Stanley is not one of them. I buy that through a secondary source. The Stanley is the hinge that I absolutely prefer the most, and it's because the fit and finish of the Stanley hinge is always beyond acceptable. It's actually beyond amazing. Other manufacturers do not finish their hinges as well as Stanley, meaning when you look at the hinge leafs and the finish applied to it, no one matches Stanley's fit and finish, period. They're bearing hinges, they're ball bearing, they're standard 5 or 3 knuckle, 5 knuckle standard heavyweight, they're concealed bearing material, phenomenal. They put hinges out, they have a full complement of hinges that is complete. If they don't make the hinge that you want, it's likely that you don't need the hinge. Occasionally someone will call me up and ask for a 12-inch wide throw hinge. Stanley doesn't make that. No one does. Well, that's not true. You can have it made, but the last time I quoted that hinge, it was $1,000 each. Below this video is a link to the manufacturer's page where you can pull up the several and many Stanley catalogs. Their name is tossed under an ever-increasing umbrella where they're currently connected with Kaba Ilko, Dorma, Precision, National, Best Lock, others that I'm probably just simply not familiar with or aware of. And through it all, they continue to make a high-quality product, and it would be the hinge that I would use. I don't have personal experience with this model. I don't have any reason to be suspicious of it, except that I would use it within its 75-pound rating, because when I took my hand on the base and could move it, that tells me it's a lightweight hinge. A medium hinge I wouldn't be able to move much, and a heavy there is a company that makes a heavier version. It's impossible to move because it's rated for a 150-pound door. Any questions on the Stanley BB159 or any other Stanley product, please feel free to reach out to us. And thank you.